This is the solution video for question 16 from paper 2 of the 2019 TMUA or CTMUA exam. In this question we're asked to consider this quadratic y equal to px squared plus qx plus p, where p is greater than 0 and p and q are both real constants. And then we're told that this quadratic intersects the x-axis at two distinct points. Given this information, we're asked in which of the following graphs does the shaded region show the complete set of possible values for p and q, so we have an intersection at two distinct points, with these 8 graphs below. So we need to deduce when this quadratic has two distinct roots. We don't care what the roots are, we just need to know there exist two of them and they're not the same. So to do that, we immediately jump to the criterion we always look at when we have quadratics and we want to look at number of roots: discriminant. So what's the discriminant of this quadratic? Well, q squared minus 4ac, so p times p, so q squared minus 4p squared. And what do we want? Well, we want two distinct roots, so we want the discriminant to be greater than 0. So q squared minus 4p squared is greater than 0. So let's move the 4p squared over, so q squared greater than 4p squared, and it's fairly easy to deduce from here that this means that q is bigger than 2p, or q is less than minus 2p, because remember p is greater than 0, so we know this is what we have. So now we've just got to look at which of our graphs corresponds with this. So let's zoom in on our possible graphs. So we're looking for q equals 2p and q equals minus 2p as lines, which we see appear in E here and F here. But we know that q is greater than 2p. So we want the above the top line to be shaded in. And so we see that F is the graph we want, not E. And so our answer is F.